this lesson, we're going to go on and continue to work with our functions. In the previous unit, we spent our time working with just linear functions. Now we're going to look at some other common functions. The first one, f of x, remember that's just another way of saying y. This function of x equals x is called the identity graph. It's called an identity because no matter what x is, the y value is the same for this graph. So it has points on it that are like 0, 0, 1, 1, 2, 2, 3, 3, -3, -3. This is the identity graph. This one is the squaring graph. If you take 0 and you square it, you get 0. If you take 1 and you square it, you get 1. If you take 2 and you square it, you get 4. 3 squared is 9, and that's why it rises quickly. The same thing happens for negative numbers because when you square negative numbers, that value becomes positive also. This shape is called a parabola, but usually I refer to it as kind of a U shape. The next one is the square root function. It takes the square root of numbers. Now, although we will study this more in a future lesson, you can only take the square root of numbers that are not negative. So you can take the square root of 0, which is 0. You can take the square root of 1, which is 1. The square root of 2 is a decimal, 1.41. The square root of 3 is a decimal, 1.73, and it goes on. The square root of 4 is 2. You get this little increasing graph, which I call a branch. The last one we're going to use in this lesson is the absolute value graph. The absolute value is indicated by straight bars. When you take the absolute value of 0, you get 0. When you take the absolute value of 1, you get 1. But when you take the absolute value of -1, you also get 1. So absolute value takes a number and essentially strips it of its sign, so that positive numbers are positive absolute values, but negative numbers also have positive absolute values. As we talk about some things called transformations, we're going to use these 4 functions as examples. When you go on to college algebra, you will study more transformations and you'll study them with other kinds of functions. Now, a transformation is when you, let me erase this, I apologize, some bad graphs. The transformations are when you do things that cause your function not to really to change its shape, but to change its position. So the first one, it says these are vertical shifts of functions. If you have a function, f of x, it could be the absolute value, the square root, it could be any of those that we've talked about. If you take it and you add a constant number to it, that makes a new function which has shifted up. If you take a function and you subtract a number from it, it creates a new function which is the original one shifted down. Now, let's take a look at what that means. Suppose you have f of x is x squared, and you have g of x, which is this function, x squared, but you add a constant to it. That means that the graph of g will look just like the graph of f, but it will be shifted up. Let me do an example. The f function is in blue, and it looks sort of like this. It's just a sketch. The g function will be up 3 units. 1, 2, 3. It will be the same shape, but it will be shifted up 3 units. All right, let's look when you have, say, f of x is the absolute value of x, and g of x is that function, absolute value x, minus a 2. That means it's going to shift down. All right, the original looks like this. It's a V. If I shift it down 2, I don't change its shape, but I go down 2 units. a little hard to tell, but this bottom point is supposed to be at 0, -2. All right, so those are vertical shifts. Next, we're going to look at some horizontal shifts. These kind of surprise you a little bit. It says if you add or subtract a constant to the value of x before the function gets to act on it, then it shifts it right and left. But what surprises people is if you subtract, it goes to the right, and if you add, it goes to the left. It goes the opposite direction of what your instincts tell you would happen. So, as an example, suppose you have f of x is x squared. And you look at let's look at g of x. Suppose it is x plus 2 squared. All right, now when I add 2, it's going to go to the left. So in blue, the original looks kind of like this. If I add 2, and I add the 2 to the x's before they get squared, it shifts to the left. I know that you think a plus would go to the right. It does the opposite of what you expect. Now, if you have f of x is, say, the square root of x, and g of x is the square root of x minus 2, it's going to go to the right. 2. I know that's not what you necessarily expect, but it is what will happen. So here's what the f function looks like. It's that branch. If you subtract 2 from x and then take the square root, it's going to shift 2 units to the right. It's going to look the same, but it's going to be to the right. So we have up and down shifts, vertical. We have left and right shifts, which are horizontal. There is one other kind of transformation, which is not a shift. It is a reflection about the x-axis. It says if the graph of g of x is equal to negative f of x, is the graph of f of x reflected about the x-axis. All right, translation, what that means is, suppose you have f of x is equal to x squared, and g of x is negative times x squared. Well, we know what x squared looks like. It is the parabola, which looks rather U-like. Negative f of x, it causes a reflection about the x-axis. So everything that used to go up now goes down, and the graph looks like this. Okay, so it is reflected about the x-axis. Positives become negatives, and so on. So we have vertical shifts caused by adding or subtracting on the outside of the function. We have horizontal shifts, which go left and right, but if you add inside before the function takes place, then you've got a left shift. So now let's look at some examples and try to use these concepts of transformations on these example functions. Okay, let me make this a little bit larger. All right. Now, in these, you're not going to be doing the graphing. They're in MathLab. They're going to be multiple choice. That makes it a little easier. All right, starts out and it says sketch the graph, but you're just going to select it. All right. First thing I want you to notice is that it is an absolute value, so it's a V shape. The next thing is that there is a +4 after the absolute value. That means it's going to shift up 4. So you're looking for a V shape. Well, they're all V shapes. The regular absolute value has its lowest point at 0, 0. So you're looking for one that's shifted up 4. This one, and by the way, I think these maybe are marked off by 2's. This one has shifted right 4. This one has shifted down 4. This one has shifted left 4. This one has shifted up 4 because each mark is 2. So this is the correct one. So make sure you identify what shape it's going to be and then which way it shifts, or is it a reflection. All right, the next one, it is a square root function. Now the square root function is the branch. It has a -3 on the outside. That means it's going to shift down 3. All of these are the same shape, but this one, once again, the tick marks are counting by 2's. This one is left. This one is right. This one is up. This one is down. We were looking for the one that was shifted down. The next one, it is an absolute value graph, which means it is a V shape. Because it has a +5 inside, it's going to shift left 5. Remember, when it's inside the absolute value in this case, it goes the opposite direction of what the sign says. So left 5. And these are marked off by 2's. And left 5, this is the only one that has shifted to the left. So it is choice A. This one has a square root, which means it is a branch. And it has a +7 inside. So it's going to shift left, because plus means left, 7. And this is the one that shifts to the left, 7. All right, let's look at the next one. It has x -10, and then it's squared. So it is a squaring function, which means it's a U shape. And inside the square, it has a -10, which means it's going to shift right 10. When it's inside the function, whether it's inside squaring, inside a square root, inside absolute value, when it's inside one of those, a minus means it goes to the right. So I'm looking for a U that instead of being at 0, 0, will shift to the right 10, and it looks like it's this one. This has moved over 10 because it counts 2, 4, 6, 8, 10. All right. Am I on 7? Nope. I am on 6. All right. This one is a squaring function, so it's still the U shape. And it has a +8, but this is happening outside of the squaring. So this is going to shift up 8. So when it's outside of the squaring, outside of the absolute value, outside of the square root, it shifts it up or down. So a U shape, up 8, and that will be choice B. All right, the next few have 2 shifts, vertical and horizontal. This one is going to be a branch because it's a square root. Inside it has a -4. That means it's going to shift right 4. Outside it has a +2, so it's going to shift up 2. Inside is left or right, opposite of what the sign says. Outside is up or down, but it is what the sign says. So I'm looking for a branch, and typically The branch has its lowest point at the origin, but that lowest point will be right 4 and up 2. And these are counting by 2, so up 2, 4, that's right 4, up 2, here it is. Number 8, absolute value. So it's the V shape. The -5 on the inside says you will shift right 5. The -5 on the outside says down 5. Right 5, down 5. Right 5, down 5. It is this choice. You were looking, typically the V has its lowest point at the origin, but I was looking for one that had shifted right 5 and down 5. Number 9 is a square root function. The square root function is the branch. Because it has a +3 inside, that's going to be left 3. It has a +2 on the outside, that's going to be up 2. And you're hearing a strange noise. I'm sorry. I have a dog that coughs, and my coughing dog has come into the room. His name is Duke, by the way. All right, so I'm looking for a branch that has shifted left 3, but up 2. Left 3, up 2. If you're counting by 2s, this is it. Number 10, absolute value. That means it's a V shape. Inside +5 means left 5. Outside -7 means down 7. So you're looking for a V that has shifted left 5 and down 7. And it will be this one. And the last one, squaring function. So it's a U shape. Inside is a -1, so that is right 1. Outside is -2, so that's down 2. You're looking for a U shape that has shifted right 1 and down 2. And you don't have to worry that Math Lab is going to try to trick you. Is it right 1 or right 1.5? There is only one graph that has shifted right and down, and the numbers will be correct. Okay, there are not any reflections in this exercise, but I just thought it was good to go ahead and talk about the fact that not only are there horizontal and vertical shifts, but there are reflections. You'll look more at those at college algebra.